Hello everyone. Welcome to this session about Groovy and Android. So before I start, I caught a cold, so if I die before the end of this session, just remember that you can use Groovy and Android and I will be happy. Just how many of you are Groovy developers in the room? Okay. Android developers? iOS maybe? Okay, a few hands. Right. Let's start. So, a few words about me first. I work on the Groovy language, so I am employed to develop the Groovy language. I really started using Groovy maybe 6 years ago as a user, and then I became a committer. And now I am working to implement some features in Groovy. So I worked, for example, on the static type checker, the static compilation. I implemented traits. Well, a lot of the stuff that you see since Groovy 2, actually. And the reason why I am here today is that I also implemented the support for Android in Groovy 2. Well, check out my GitHub account. You will have the slides for this talk as well as code samples on my GitHub repository. So don't hesitate to take a look. Okay, let's start. So the first question is why choosing Android actually for Groovy. So the first reason is that Groovy and Android are both based on some kind of JVM. So it's not really true for Android. I will come to that later. But basically, it's Java, right? Even if you can do some native development, you likely use Java as the first choice language to develop Android applications. Second reason is that the SDK is free, so it's really easy to get started if you have never done any mobile development and you want to try to play. I think that Android is quite a good platform to get started with, especially because there's free tooling. So in this talk, I'm going to focus on Android Studio. And one last reason is maybe not why Android, but why not iOS? And one of the reasons is that when we announced actually that you could use Groovy and Android, Apple, the same day, announced a new language, Swift. So how many of you know about the Swift language? Right? So if you have friends programming in Swift for iOS, actually you would see that the language is pretty close to what you have with Groovy. So there is no real reason for us to invest in having Groovy and Android on iOS, because actually the language is pretty close. If you are a Groovy developer, you will know how to develop with Swift. Now, why Groovy? Okay, it works. So why Groovy? So as I said, it's working on a JVM. It's a JVM language. Android also runs on the JVM, but the main reason for me to start this development is actually the third bullet point. Java developers should not suffer, you know. If you use Java on Android, you are suffering. And I will show some example of code that makes you suffer. And us, as Groovy developers, if you have done Groovy for a long time, it's very unlikely that you want to come back to Java. So let's illustrate that in this talk, and hopefully at the end you will be convinced that you wouldn't want to switch back to another language. Groovy is we call that multifaceted language. So what does that mean? Basically, it's just that Groovy lets you program in multiple ways. You can do object programming, imperative, functional, etc. So you have lots of options. And We don't say one option is better than the other. It's up to you. You can do whatever you want. It's mainly focused on objective programming. We have flavors of functional programming. We have closures, for example. So Groovy is a powerful language that lets you do multiple things, and you have actually the choice to do whatever you want. The last point is very important. Groovy is probably the JVM language which has the strongest integration with Java. So for two reasons actually. The first one is that Groovy is a language which is very close to Java. The syntax is very close. Normally you can almost take some Java code, paste it into a Groovy file, and it compiles fine. So you will see that it's very, very easy if you don't know Groovy to get into the language, because you can start with the same syntax. You don't have a new syntax to learn. So, better than slides with text, let's start with some code. So this is typical Groovy, Java code that you will find inside an Android application. So I used to say that actually Android is the anonymous in a class paradise. You know, you have to write anonymous inner classes everywhere. And this is an example. You want to set a listener on a button, then you have to create an anonymous inner class with onClick method. And in the end, the only thing that you want to do is start an activity. Well, it's a lot to write just to do this. So in Groovy, we do that. Just onClick listener equals, and this block is actually called a closure in Groovy, and you're done. This is much, much concise. You know what you do actually just reading that code, and you remove all the ceremony code. You know, you don't have to tell the compiler that you are implementing a click listener. You know, it's capable of figuring it by itself. So why would you want to do that? Just write it. Another example here. So this one is actually work in progress by someone in the Groovy community. And it illustrates several capabilities of the language. So first, you can see that we have here properties by default in Groovy. If you don't put any modifier like public, it's a property. So it's a Groovy bin, so it means that you have the setters and getters generated for you. Here we have a block, static constraints equals something, and what that does is actually defining constraints on your properties. So this is inspired from the Grace framework. Anyone uses Grace in the room, maybe? Okay, so it's for MVC development, web development. And you can define, for example, a pattern saying, okay, the name is a regular expression with a minimal maximum length. It can be blank, etc. It must not be nullable. Well, you can define some constraints. And then you can write that kind of code, which is declarative code, where you would say, okay, on my form, which ID is the user form, then with the edit text username, I can attach the name. And just by declaring this, actually, you can have validations automatically bound to your text fields. So it's just declarative code where normally you would have to write all the validation code by yourself. So don't try to understand all these block of code, because it's work in progress. It's a DSL in Groovy. Groovy lets you write that kind of code, but it's just to give you an idea of what the language lets you do. I mean, Groovy is very good at building some kind of DSLs, and this is an example. So you come from imperative code to declarative code as much as possible. So this is actually now the example that I wrote, so I would show you the application. And this is an application that synchronizes with a watch, a smartwatch. And actually, you want to build a notification. And in Java, you have to write all this just to generate a notification. And just reading that slide, I guess that you don't see what it does. I mean, you have to declare a lot, and you're using, okay, notification compat, okay, compat. I don't like that much, but actually you're kind of forced to use that in Android. You have builders taking this. You have, yeah, it's a builder syntax, so it's kind of modern API, but there's something wrong. I don't really like this. So what I have done in my application is just wrapping all this into a better API just using Groovy. And I came up with this. So it's just send a notification with the ID, and I say, okay, the small icon is this, the large icon is this, etc., the text. And all this code is strictly equivalent to all this one. And what you can see already is that here you have to define a lot of local variables. And in this case, the Groovy code one, you don't have any local variable. And this is a big difference because you have code locality. Everything that is bound to your notification is actually inside the notify block. And it kind of changes the way you think about APIs. So one question you might wonder is how you come from that, the Java code, how you come from that code to this one. Is it hard to build a Groovy API to do this? And actually it's pretty easy. So what I wrote is that code, a class called Groovy methods, context Groovy methods. And what it does is actually just define a bunch of static methods. So you have the static modifier, and the important part is actually the first argument, context. And by doing this, I am actually adding a method to the context class. And the method will be named getCompatNotificationManager. So if I have an instance of context and now call getCompatNotificationManager, it will return what this code does. So Groovy lets you extend existing classes and classes that you didn't write. And this is a very important point. And this is the very reason why actually the Android code has to write, the Java code has to be that verbose. It's because you cannot extend existing classes. So you have to use external classes and pass a first argument. With Groovy, you just switch, reverse the thinking, and say, okay, the receiver is a context, and now I have methods directly available. So the notify method here is actually this one, called on a context. So self becomes the receiver, and then you have the closure. Okay. Just another, annotations like that are very powerful in Groovy. So in the Java code, actually, I lied a bit. This code is not strictly equivalent because here I am using a cached bitmap. And what does it mean? Actually, in the Java code, you had this line, decode results, etc. So it's actually the same one, but you decode the results every time. In the Groovy version, actually, this is done lazily. Only when the notification is sent. Thanks to this field, thanks to the cached bitmap field, actually this one is initialized lazily. So you can imagine all the code that you would have to write in Java just to perform lazy initialization of a field. So that's why I didn't put that in the slide, actually. Okay. So this is actually an application that I'm using right now. So it's an application that I wrote just as a sample code that is available on GitHub, and it's for speakers. And the idea is that you know how much time you have left in your presentation, so you can speak to your watch, tell, okay, I'm doing a presentation for 60 minutes, and then actually it's synchronized with my phone here, and it tells me, okay, you have 40 minutes left. And what it does is also vibrating on a regular basis, just to tell me, okay, you have to hurry up because you only have 10 minutes left. So this application is actually written in Groovy, and it runs on wearable devices, so it can give you an idea what you can do. Right, so this was just an introduction, but before going to that, actually there are a lot of problems that we had to solve in Groovy. So for those of you who know Groovy, the first thing that you might think is, how is it possible? Because Groovy is a dynamic language. So a dynamic language means that not everything is done at compile time. In Java, when you compile a file, everything is resolved at compile time. So when you say, I am calling this method, the compiler resolves the method and says, in the bytecode, this method is going to be called. In classic Groovy, in dynamic Groovy, it's not the case. The selection of the method which will be called is done at runtime because, well, it's a dynamic language. So you can override, for example, a method at runtime or add new methods at runtime. So to do that, Groovy uses reflection. It has some caches. So yeah, it causes some problems. And on a mobile device, a watch or this one, the problem is that the more you do, the less battery you have. And on mobile devices, this is a problem. Last problem is that bytecode is different. So I said that Groovy and Java are both based on the JVM, but once you go on a mobile device, the bytecode is actually not the same, just because it's not a VM on a mobile device. So we have a problem because we generate classes with bytecode which is understandable by the JVM, but not by a mobile device. So if you do that at runtime, of course, the bytecode will not be recognized. Another problem is that Groovy relies on beans API. So as you have seen for the properties, for example, we follow the bean semantics. So we need that package. And the problem is that the java.bean package is not available on Android. We now have multiple runtimes. So there's the Dalvik runtime, which is the old runtime available for Android devices. So I am saying runtime, so it's not a JVM, it's not a VM at all, it's really a runtime, so it's a library that runs bytecode, Android bytecode. And now, since Android 5, we have a new runtime called Art that does something different, so I'm going to explain that after. So, let's go back in time, and actually, in 2011, two guys, so Eric Pracht here and Marcin Edman, they wrote something that actually ran in Android. So it was in 2011, and you might ask, okay, so if it was available at that time, why I am doing this talk today? I come to that. The thing is that their main focus was running scripts at runtime on a device. So compiling a Groovy script and running it on a device. And it was more than that, it was running the full Groovy test suite on a mobile device. So it worked, but it was a bit slow. So let's explain why it was slow actually. Oops. I should use the keyboard because it's getting crazy here. So dex files. So the dex files. What is a dex file actually in Android? So the Dalvik VM, well, the Dalvik runtime uses a different bytecode. Groovy generates Groovy JVM bytecode, and converting that bytecode to the Android bytecode is called dexing files. So it's a tool called dex that converts from one bytecode to the other. So Android doesn't have support for doing that at runtime. So typically what happens, so don't worry if you can't read that, I'm very bad at writing diagrams, so it took me a few hours just to generate that, if you, if you can imagine. So if you compile an application for Android, actually you start from Java sources, you compile them, it generates class files, then you call the dex file, the dex tool actually, and it generates a classes.dex file. Then you generate an APK, which is the installer, basically, and you deploy it on a device. So really, in the middle, compared to a classic Java application, you have a tool called dex that does the bytecode translation. In case of a Groovy application, what we want to do is exactly the same, but having Groovy source files at the beginning. So it shouldn't be that hard, but it's not what those guys have done. Okay? It's a little more complex what they have done. And why? Well, why? Just because they want to run classes at runtime. So we have a problem actually, because I told that Android doesn't let you do that. Actually, it's not really true. You can do that because they have done it. And what you have to do is to write those Groovy bytecodes into a file, okay? Package it into a jar file, and then you can use a special class loader inside the runtime, the Dalvik runtime, just to load that file. So imagine that just to be able to run a script on a device, you have to compile it, put it in a file, a physical file, wrap it in a jar file, and then you can load it. And there's no other way to do that on Android. So, yes, you know why it's slow now. So the process is this. Okay, you have Groovy files, you do everything you want, but you repeat the process. The whole process is repeated on the device. So the dex tool is called directly on the mobile device. So it does the bytecode translation. That's pretty cool. I mean, I love it. It's something which is hackish. I love to hack code. So it's cool to see it in action. But, well, it's very, very slow. And it doesn't really make sense on a mobile device to do that. There's a lot of I/O involved, etc. So it's not really interesting for us. Some of you maybe know about the ASM library. No? So ASM is the library that we use in Groovy, and maybe other open source projects do that, to generate the bytecode. And there is actually a version of ASM that is capable of generating dex, the dex format, directly. So we didn't use that because for us it would have meant to rewrite a complete new compiler just for Android. So it's a huge work to do because the APIs are not the same. The bytecode is different and the API basically is not the same. So we didn't do that. So we're stuck with the approach using a file system. So this is actually what the Ruboto library does. So Ruboto is Ruby on Android. So for us, it's a cool, nice, really cool proof of concept, but not really what we want to do. So let's redefine what we really want to do. And actually, it's pretty simple. In Groovy 2.4, so the version is not out yet, the idea is to support Android out of the box. So no fork anymore, like the fork of Groovy 1.7. Being able to build a full application using Groovy, so no Java file at all. You can mix Java and Groovy, it's fine, but our goal would be you can write your application totally in Groovy. Compile static is important. So I said that Groovy is a dynamic language. Actually, it's a dynamic language by default, but if you use an annotation called compile static, you turn Groovy into a language which is statically compiled. So to simplify, Groovy will behave exactly like Java. So no runtime method selection, the bytecode will be the same, the speed will be the same. So it is important in the context of Android because we have limited resources, we have limited power and limited battery. So using compile static is almost the only thing that you would want to do on Android. There are some cases where you could still use dynamic code, but the main focus is compile static. Second objective is actually not for me as a Groovy developer, but for you as a community. Because Groovy, the success of Groovy comes from the community. And all the libraries, all the frameworks that are built on top of Groovy. So for those of you who know Gradle, for example, Gradle, the build system, is built on Groovy. And yes, Android uses now Gradle by default, so it's a nice story to be able to use Gradle to build Android applications, and then now use Groovy to have your code. Yeah, we have the Grays, we have lots, yeah, a lot of libraries written in Groovy. And the idea is that you, as Android experts, which I am not, actually, I'm not an expert of Android. So you as experts can build new APIs, new frameworks built on top of Groovy. And the code that I have shown that simplifies all these boilerplate code in Java, just giving you closures, bringing a simple method called direct API calls is your job. So, does it really work? Yes, it does, because I have shown an application, but it's also actually deployed on the Play Store. So this application is the first one which was deployed on the Play Store, and it was for the announcement of Groovy on Android. So it's an application which was just an agenda, like the DevOps agenda for the GradeConf conference, and it's fully written in Groovy. It's using it can work on tablets or whatever, so it just works. And it's available on the Play Store. And the code is available on my GitHub account, so you can check it out. And criticize me because I'm not an expert. This one is also available on GitHub. And this is precisely what I was saying when I told you this is a bad idea to try to compile Groovy code directly on the device. So this application works, it's written in Groovy, and it's capable of compiling Groovy on the device and running it on the device. So for this Groovy code, which is actually something that you can write on the device, so writing code is not really easy. So you can do that, but you have to be patient. You compile it, and you see that actually on this one, which is Node 3, which is, well, I would say quite a powerful Android device, compilation takes more than 1 second. After that, running is not, it runs quite fast, knowing that this is actually dynamic code running. I didn't put compile static on that code, so it's really dynamic code running on the device. So, illustration of why it's not really interesting to do that. Okay, so now the question you have is, how can I do that? So the requirements now are using Gradle. So Gradle is the new default build system for Android. So the only supported way to have Groovy on Android is to use Gradle. There's a plugin. The second one is probably Android Studio, because it's well integrated with Android and well integrated with the Gradle build system. You can use Eclipse, but I know that if you do use Eclipse, actually you have to switch to, I think it's a third-party compiler. Groovy 2.4 beta 3. So don't be afraid by the beta part, because it's still in beta because we're not feature complete for Groovy 2.4, but the Android part is pretty stable. And the last one was especially for me, because when I started that, I was a total Android noob, so I learned Android developing a Groovy application with it. And it was interesting, actually, because I wanted to feel the pain of going back to Java and not Java 8. You know, you don't have lambdas in Android. You have more like Java 5 code or Java 6 if you're lucky, APIs. So it's really, really painful to write. So first of all, when you do that, actually you have to use a specific classifier which is named Druid. So you cannot use the normal Groovy jar, you will use the Druid jar. So the reason for that is exactly what I have explained. There are some classes missing from the Android SDK, so the classes, for example, from beans, which exist on traditional JVMs. So this jar actually adds all the missing bits, plus some workarounds which are specific to Android. So, last point. In Groovy 2.4 beta 2, I think, we dramatically reduced the number of methods that Groovy generates. Because if you look at the bytecode that Groovy generates, since it's a dynamic language by default, it has to use a lot of helper methods, and those were not strictly necessary all the time, so we optimized that, and it's really important in the context of Android, because you know that there's the infamous limit of number of methods, and especially if you start using the Google Play services, libraries, etc., it's very easy to reach that limit. So hopefully now there's the multi-deck support in Gradle and the support library. I think it's been released 2 or 3 weeks ago. So it's much easier now, but still you will probably face that limit. So what you need to do is apply a plugin. Say I'm building an Android application, you can use a library. And then you apply the plugin specific for Groovy that adds support for Groovy on both the application and the library side. So the same plugin works for both. You don't have to apply a Groovy library plugin or a Groovy application plugin. The same plugin does both. So what does it look like in real life? Well, your Gradle build would be quite simple. You just add the plugin to the class path, apply the plugin, and then add the Groovy version and the Groovy classifier. And you're ready to go using Groovy. What does it mean to code in Groovy? Well, then I can do that. I can use all the features of Groovy. So I will put compile static because by default, okay, I'm on a mobile device. do compile static. And then I'm using the toString annotation, the features from Groovy, and the toString annotation with include names would just generate the toString representation of that bin. So I don't have to write it. Why would I want to write code which is code that the compiler can generate for me? So this is the kind of stuff that you will have for free with Groovy. And yes, I think it's quite cool to have equals and hashcode generated for me too. So just add an annotation equals and hashcode. There are shortcuts. You can use canonical, you can use immutable, you can use a lot of annotations in Groovy, and those annotations will do the job for you. Cool. But that's not all. Do you like the AsyncTask in Android? Probably not. It's a very, 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 very displeasant API to work with. So it has, the reason for AsyncTask to exist is very simple. You have to do long-running task on a separate thread, not on the UI thread. Otherwise, you block the UI. So AsyncTask is there to do that job. And yes, we're in the anonymous in class paradise. So each time you have something that does network operations, you have to write that kind of code. I know that there are libraries out there that simplify that too, but I want to use Groovy. So what I did is actually generating code which looks like an AsyncTask, but using Groovy. So imagine that I just want to parse some JSON feed remotely, so it is a network operation, and then when I have stopped, when I have grabbed actually all that, I want to update the text field. So in Groovy, I can write that kind of API. So I have used Fluent, but whatever the name, it's just an example. What it says, do asynchronously, sorry for the accent, do async this code, and then when this is completed, update the text field. So it actually is an implicit parameter that you have in Groovy. You'll get used to that if you don't know Groovy. It's basically the, you could use here string speakers, say, yeah, string speakers, arrow, and then use speakers here. But the compiler is able to infer that. So I am using the JSON slurper, which is a Groovy specific library. I give the URL, and then I am using a feature of Groovy, which is the JPath. So I don't have to build a model for my JSON code. I can use the dynamic features of Groovy. So this is an example where actually keeping dynamic features in the device could be interesting, because I want to rely on the dynamic features of Groovy to get the speakers element of my JSON feed. So this case is very simple, but you can imagine that you could have, for example, JSON.answer.conference array 0.speakers, etc. So you have a full path without having to generate beans like you would have with other libraries. So it's pretty easy, pretty straightforward, and actually it reads very fine, I think. If you disagree and you can't read that, just come to me after the session. We can discuss that. So mobile development is also about performance in general. And yes, it's a new language. Is it performant? How much resources does it consume? So as an example, I took actually the application that is deployed on the Play Store, so the Agenda application. And first thing that you will notice is that the Groovy jar, the Druid jar, already takes a little more of 4 or 5 megabytes. Okay. But once you compile it and once you get the APK, actually the APK is reduced down to 2 megabytes. So doing nothing, just compiling, just using the regular Android toolchain, you come down to 2 megabytes. Okay. But if you add the ProGuard tooling, so ProGuard will basically analyze your code and eliminate all the unused code from the bytecode, from the jar, from the classes.txt, etc. Well, I can reduce that to 1 megabyte. So I have an application, a real Groovy application written Groovy, yeah. And it's only 1 megabyte. So compared to cat videos on YouTube or whatever application that you download on the Play Store, I think it's pretty good. So you can say basically that the cost of bringing Groovy into your project is low. What about memory? So hopefully there are tools to analyze memory on Android, and I've performed the dump of the memory used by my application, and it was using 8 megabytes of RAM. But what I noticed actually is that most of that memory was just to store the pictures of the speakers. So probably something to optimize there, but well, it's Groovy running on a mobile device and it doesn't consume that much memory. So I think it's pretty cool, because often people tell us that Groovy is not performant, Groovy consumes a lot of memory. That's not true. At least on the mobile device, we have the proof that it's not true. Let's talk about the community. So I said that the community is very, very important for us in Groovy. So actually, there are some projects which are starting to develop in the Android world based on the Groovy language. So the first one is swissknife. So maybe some of you know about Android annotations and butter knife. So it's some kind of library that brings the same kind of APIs, but on Android for Groovy. So what it will provide you is that kind of code. So you can annotate, for example, a field with view by ID, saying the ID, and saying that it's a text field. All the injection is done for you. So you don't have to write the code that you see in lots of onCreate, whatever method, saying, okay, I want to find view by ID, then cast it to the text field, etc. That code is written for you, generated for you by the compiler. You can annotate a method with onClick, and then it will add the listener automatically, and this method will be called when the button is clicked. In that case, you have another example of background processing. So in my previous example, I was using the Fluent async API, but there, using swissknife, you can annotate with onBackground, and actually that will run on the background without having to declare it, without having to do anything to create an AsyncTask, whatever. And the only thing that you still have to do, but this could be added automatically by the Groovy compiler, is just to call inject, just to perform the injection of fields. So by a single line, you replace all the casts, all the find view by ID that you had. I think it's pretty cool to have that. Another example of APIs is the Druid tools. So Druid is the name of the Groovy for Android project, and Druid tools is something that tries to bring the goodness of builders for the UI inside Android. So in Groovy, builders are at the core of a lot of APIs. So the idea is that you have a hierarchical data structure to build. So this is a typical case with the UI. You have a view that embeds other views. You have a tree of view elements. And builders are very powerful to build that. So you can create an Android builder, and then you can say, okay, relative layout with the width, the height, etc., the padding, and inside that view, I will find a text view, etc., etc. So you can build your UI using a builder syntax rather than relying on the XML files or, sometimes you have to build those programmatically anyway, even if you rely on XML files. So this is a good way to have code which is focused on what you build and not how you build it. The difference is really important. You as a developer should not care about how. You should care about what you want to build. So in this case, you don't have to use the add element. You don't have to declare a lot. So all the code that you see is actually the code that you want to see. There's no boilerplate code, not ceremony code. So far, so good. Okay. There are some issues. There are some issues for using Groovy. Hopefully not many issues. First one is, as I said, devices. Devices are not powerful. So I am lucky to have a powerful device, but most of the devices that you find on the market are not so powerful. So you have to care when you build an application about performance. So this rule, use compile static whenever possible, is really important. I showed in the JSON example that you may want to use dynamic code in your application, but if you do, limit it to where you know the code will not be called often. So typically, if you build a UI, it's done once, but if you have some operation which is repeated constantly, don't rely on dynamic code because it will be slow, because on Android we don't have the cold site caching that we do in the JVM, so everything relies on reflection. And reflection is awfully slow. It is slow on a JVM, it is worse on a device like that. Second one, the limit of the number of methods. So it's true that when you add Groovy, you add a lot of methods. Well, it's by design, because Groovy adds a lot of methods on existing classes. So this is the example that I showed at the beginning, saying that you can enhance existing classes. So Groovy does that by default. Groovy comes with a number of methods available on classes of the JDK. So for example, you could call getText on a URL. And this is not a method which is available in the JDK on the URL. So Groovy adds a lot of methods. From memory, it adds about 8,000 methods. So if you use Groovy, you will reach that limit. So you can use ProgWard and use the multidex support if you find that problem. So it's not as complicated as it used to be, just because Google released a support library for multidex files that does all the hard job for you. I totally skipped the problem of tooling so far. So tooling is two things. It's the build tool, so using Gradle, but it's also the IDE. So I focused on Android Studio, and the problem is that Android Studio uses a forked version of IntelliJ IDE, and it's not up to date. So for example, if you use the traits feature of Groovy inside your application, you will see red code everywhere. So it's not that fun. So you have to know that. You have to know that some features might not be recognized by the IDE. The good thing is that to build Android Studio relies on Gradle, so it won't fail at compile time. You will still be able to build your application even if the IDE shows errors. So yes, you have red code, you might think it an error, just compile it and it works. Last but not least, the support from Google. Yes, because the Gradle plugin and even Android Studio updates very frequently, and it breaks often. So I think you know that if you use, if you use to write Android application, you must know that if you upgrade your IDE, there are chances that the IDE refuses to build your project just because you're not up to date. So you have to upgrade your build, you have to upgrade your plugins. So this inspired some guy in the US. I said that. Is it a good idea basically to upgrade Android Studio just before doing a conference about an Android project? Yes, what could possibly go wrong? So this is exactly what I did before this talk. And I'm lucky. It went well. Another topic is that, again, the community is important, but you may already use some third-party libraries in your current Android projects. So some of you may be using Dagger. The problem is that Dagger for dependency injection works on Java files, so you will not be able to use it in Groovy if you use Groovy files. So this is something that we're investigating, especially because Dagger 2 uses annotation that we could process on the Groovy side quite easily, because all the annotations that you've seen, like toString, compile static, etc., are actually processed by the Groovy compiler, and we could process the Dagger annotations too. The data binding APIs is really something that annoys me, because we're used to having a lot of fancy data binding APIs for web development, typically. So if you want to update the view when some bin is updated, you have to wire everything by hand. It's very complicated to do that in Android. You have some libraries that do that, but not really a standard one. So in Groovy, we have lots of frameworks that do that. For example, on the website, we have Grace, obviously. But on the desktop side, we also have projects like Griffin. Griffin is for building Swing, well, not only Swing, but mainly Swing applications using Groovy and using our APIs, our data binding APIs, etc. So it's really nice to have that, and it would be very nice to have that in Android too, using all the features that we can provide with Groovy. And last point is about reactive APIs. So I think it was on Monday that Venkat talked about reactive applications. So this is the hot topic today. It's that hot that actually everybody wants to do reactive applications without knowing what reactive means, actually. So you can do reactive applications with Groovy already. You can use Reactor, for example. You can use RxJava. RxJava is typically an API that would help you get rid of the AsyncTask library. And the good thing is that it is written in such a way that you can use it with Groovy for free, and having all the syntax enhancements that Groovy provides very easily with RxJava, for example. So you could use closures instead of anonymous in a class again. So RxJava plus Groovy is really a good fit, especially on the mobile side. So as an example, you might ask if you can use Groovy today in your applications? And the answer is some already do that. And the New York Times is actually rewriting the whole application in Groovy and using RxJava. So be confident, even if Groovy 2.4 is in beta state. Actually, as I said, the API is pretty stable, so you can do that, and you can use it in production. So maybe you want to see actually that in action, so I will try to run that. Try to show my simple speaker time application. Yips. Wrong screen. It's too big. Okay, so this is a typical Android Studio environment for those who don't use that. It's very easy to use, and what I wanted to show you is obviously not showing up here. Why is it that big? Hey. Show me the build at Gradle 5. Sorry? I don't know, it seems to be stuck. Yeah, it doesn't do anything. That's annoying. Come on, show me. No, because you use compile static and you have all the feedback at compile time. I don't know, yeah, I don't know. So, okay, I won't be able to show you because it seems to be stuck. Maybe if I restart the IDE, it will be better. So you see when I talk about tooling problems, what it means? Hey, it's back. Restart, as usual. Here you go. So this is a typical Android application that you can find. So you have the Gradle build file. As I said, you can have the specific Groovy configuration. And what is interesting in this application is actually that it is a multiple project application. So I have a module for the mobile device. I have one for the wearable device, and I am using two modules. One is shared and one is extension. So the extension is actually a module where I have defined my extension methods. So the methods that I wanted to add to the context class. And the shared one uses traits actually. And it is used to set up the communication environment between the wearable and the mobile device. And actually this code, this block of code that you have to write that connects to Google Play services, is code that is exactly the same on the mobile side and on the wearable side. So it is extracted in a common module that I'm going to show here. So not the extension, but the shared one. So I have source Groovy, and I have actually a Google API provider, which is a trait. Can you read that in the last row? So as I said, the problem typically is that you have the trait keyword, which is not recognized by the IDE, but you can compile it. And you can compile it, and it will run on the device. So don't be afraid to use that. I did, because I wanted to have that trait available, and that trait, what it does is basically adding a Google API client to every class which implements the trait. And all the setup of building the API client for wearables, connecting to the API and adding the listener is code that is totally shareable. And in Java, it's very hard to share that because you want to inherit an interface or you want to extend a class and actually cannot because you're already extending activity or you're already extending service, etc. With traits, you have that ability to share some fields, some state between classes. So interesting. Apparently I'm running out of time, so let's go back to the slides. Yep. And questions? Yep. So, are there any questions? No questions? Don't be shy. Do you want to use Groovy? No? Yeah? Yeah. Say it. Yeah. Thank you.